RAX will be launched from Alaska's Kodiak Launch Complex in November 2010 and inserted into a 650-kilometer circular orbit. The spacecraft will be tumbling after deployment but will stabilize about Earth's magnetic field using a passive magnetic control system. Once the attitude is stabilized and checkout operations are complete, RAX will start its science mission over the auroral zone in Alaska. On the day of an experiment, RAX will cross into the yellow experiment zone and activate its onboard radar receiver. The radar station on the ground, called Pfizer, will then transmit 2 megawatt radio pulses into the ionosphere, and the signals will be scattered by the plasma anomalies inside the green ring. RAX's receiver will then capture these signals and record it to its onboard flash memory. After an experiment, the science and mission operations team will upload processing parameters to the spacecraft from one of the mission's ground stations, as shown here. These parameters will be used by a dedicated onboard computer to condense the 1.2 gigabytes of raw experiment data into a much smaller file for download. Once the processing parameters are received, RAX will spend anywhere from 15 minutes to 2 hours processing the experiment data and compressing it into just 1 or 2 megabytes. Once processing is complete, RAX will downlink the science data to our ground station network. This process will be repeated every day for 1 year. By mission end, scientists will better understand the physics behind FAI and eventually be able to create forecast models to predict their formation.